time we did, I gave you guys 2 assignments. I don't suspect that probably everybody completed both of them. If you did, that's great, but I suspect there's probably still some questions. We didn't do a ton of examples on the solving, and I suspect that there's probably some questions there still, and that's okay. Anybody got anything they want to start with? Leo?
Reading number 4 on homework 3.
Sure. Oops. Number 4 on homework 3. This one. Okay? So this is definitely not a proportion, right? So I'm going to do the clearing fractions technique on it. I know it's not a proportion because I have, like 2 things being added on that left-hand side. Well, to clear fractions here, it's pretty easy because there's really only one denominator, and that denominator is x, right? So I'm just going to multiply both sides by x. So when I do that, 4x or 4 over x times x just becomes 4. X times x becomes x squared. And 5 times x is 5x. Now I didn't write that out with like but there's no fractions really to speak of, so I didn't bother writing that out. I just kind of drew what I did there. Walter? So anything I do to one side of the equation, I must do to the other to maintain equality. So that's why I had to multiply both sides by x. Is that okay? Yeah. Like how we have to subtract from both sides when we're solving or whatever, the same idea. Okay, so what I'm left with here is a quadratic. To solve this, I'm going to get everything onto one side. So I'll subtract 5x squared from both sides, or 5x from both sides, excuse me. And I rewrote it so that it's kind of in that standard form. Still doing okay, Leo?
Yeah.
Okay. So to solve this quadratic, I can either try to factor it, or I can definitely use the quadratic formula. If I look at this one, though, I notice this is something that I can factor rather easily, and that's usually faster than the quadratic formula. So 2 things that multiply to give me 4 and add to give me -5 are -4 and -1. So when I solve that, I just get the solutions of 4 and 1. And when I go back and check that, neither one of them is going to give me a 0 denominator, right? 4 over 4 and 4 over 1, neither one of those give a 0 denominator, so.
Right. How do you double check it?
So you're just going back to the original problem and plugging your answers in to make sure you don't get a 0 in the denominator. In this case, since the denominator is x, there's not much to check, right? But you do need to just take a second and make sure. It doesn't happen very often, but it can happen, and we do need to be mindful of it. It just takes, usually just inspection is enough. You can just kind of look at what it is. And you don't have to do a whole lot more than that. Does that feel okay there, Leo?
Yeah.
Okay. Walter.
I have no more access to my notebook. Okay.
Oh, it's a OneNote thing?
Yeah.
Sure. Yeah, this has been happening with students, and I don't know why it's happening. But it's
We bring it to IT.
well, it seems like they don't really know what's the problem with this either. Let's check something real quick though, because think in a lot of cases it hasn't really made a difference. So let's check to just make sure that I can see this when it's coming through. So I did this. I'm just checking to make sure I can still see your edits on my end. So I'm syncing my notebook now after you did that and seeing if I can see anything. It'll be a minute for it to come through because it looks like you just finished syncing up to your end, and we'll see if that comes through on my end. Yep. So it seems like it's still working. I don't know what that error is really trying to say, but it doesn't seem like it. I mean, for now, I would not worry about it. But if you're like, hey, I did this thing and you said it was missing when I'm checking homeworks, like, let me know and we can revisit. Does that sound okay?
Yeah.
Okay. So I think right now it doesn't seem like it's actually affecting anything, whatever that message is about. And several students have gone to talk to IT and it doesn't seem like they really understand why that message is coming up either. So until it's an issue, let's just just kind of ignore it, I guess. Great. Who else? Do we want to talk about some others here on this sheet? Happy to do some more. Evan.
7.
7? Okay. Great. So I would start by trying to factor things, but if I look at this, there's really no factoring to do. This is certainly the case where we don't have a proportion, though. So I'm going to identify a least common denominator and multiply both sides by that least common denominator. In our case, that least common denominator should be x times x plus 6. Are you good with that, Evan? Yeah. Okay. So I'll multiply both sides by that least common denominator. I'm just going to write LCD rather than trying to write all the symbols there. Okay, so I went ahead and I distributed that LCD through and rewrote the problem. So now I'm going to do my reducings. Which leaves me with this. So far, so good? Okay, I'm going to multiply everything out and combine like terms. I'm going to kind of just do that in one step, though, if that's okay, Evan. So I'm going to have an x squared. I'm going to have an x plus another x is 2x, and then still have that plus 6 rolling around. And that's going to give me 2x squared plus x. And I'm going to move everything onto one side. So I'm going to subtract the x squared from both sides, subtract 2x from both sides, and then subtract 6 from both sides. So I moved everything onto the right-hand side just so that the leading coefficient would still be positive, because it makes factoring a little bit easier if that's the case. Certainly you could have put everything on the other side, but then you'd probably have to use the quadratic formula because the factoring wouldn't be quite so trivially easy, or you'd have to take your greatest common factor of a -1 out or something to make it a little bit easier to factor. So far, so good, though? So again, we can solve this by factoring, or if you didn't notice it was factorable, you could use the quadratic formula. That's fine too. So when I do that, multiplies to give me -6 and adds to give me -1 is -3 and +2. So my solutions would be 2 and +3 and -2. And if I go back and check, if I plug either one of them into x plus 6, I don't get 0. And if I plug either of them into x, I don't get 0. And we already checked x plus 6. So those two solutions are both valid. And we're all done. Does that feel okay? Again, if I went too fast through something, or not sure what I did, or you need me to say it again, or whatever, let me know. I can surely do it again, or say it again, or do it differently, or re-explain, or fill in some blank, or elaborate on something. Happy to do any of that. But that satisfied you, Evan?
Yeah.
Okay. Good. What else? Go ahead, Ev.
Number 2.
2? Sure. Okay. So here, this is a proportion. So you could do this by cross multiplication. That would be fine. So I'll multiply that stuff together and that stuff together. Notice I'm not worrying about factoring anything. You could certainly factor it if you wanted to start, but it's not going to really help with the cross multiplication steps. If you wanted to factor it at the beginning, I would end up just clearing fractions then. I think if you're going to bother to factor in the beginning, clearing fractions would be a better option for us. Which is fine. You can certainly do that still. So I went ahead and cross-multiplied and then distributed everything through. Now, what I'm left with is a polynomial, so I'm going to get everything onto one side. So I'm going to subtract 9x squared from both sides. And then add 27 to both sides. And now to factor this, I'm going to notice, oops, I wrote a squared, that was a cubed. I'm going to take out a greatest common factor of 3x. Um, 54 divided by 3 is 18, I think. Is that right? Yes. So far, so good?
Yeah.
Okay. Now we'll try to factor this. So two things that multiply to give us 18 and add to give us -3. That's going to be -6 and -3. And then when I solve this, I get 0, 6, and +3 as my three solutions. Are you okay there? But we still need to check When I plug 0 into this denominator, I get 0 minus 0, which is 0. So I'm going to discard that one. Let's do that in a different color, maybe. When I plug 6 in, I get 36 minus 36 plus 9. That's good. And then 36 minus 18, so that one's good. So 6 is good. When I plug 3 in, I get 9 minus 18 plus 9, which is 0. So that one fails. So we have just the 6 as our remaining solution. Is that okay?
Wait, how did you show me again how 3 fails?
Yeah. So that gives me 9 minus 18 plus 9 when I plug 3 into that one. And that's 0. It also is 0 over here also, because that's going to be 9 minus 9, which would also be 0. It doesn't need to give any 1 0 denominators enough to throw it out. Doesn't matter which denominator makes 0. In this case, it worked for both denominators. Or I should say fails in both denominators. You know what I meant though, right? Okay. Does that feel okay? Okay. Again, like if I shortcut through something or I get a little too hand wavy about something and you didn't follow what I did, definitely follow up. I'm happy to go back and re-explain and elaborate. No big deal, right? Like telling me what you need is no problem. We can do more or we can do less, depending, whatever you want. Well, why would I do that? Can it all just stay there? All right. Feeling a bit better about these solving problems here after doing a couple more examples. Again, typically, once you kind of get through that first step and get rid of the fractions, you're left with a problem that should feel pretty familiar in terms of solving. They just kind of turn into, like an easy chapter 5 problem or a hard chapter 4 problem in terms of solving something. Most of them were factorable, I think, so you didn't even really have to, I don't know that you even had to use the quadratic formula at any point on this sheet. I tried to keep right problems where things were factorable. So where are you guys at here? Let's have a conversation. I know we came back from break, right? And we're a little rusty on things, and that's okay. We did some new stuff yesterday. How many of us were able to finish the stuff from yesterday? Okay, so some of us maybe attempted everything, but are like, after doing some stuff now, I need to at least go back and rework stuff. Some of us maybe got to a point where it's just like, I did a little bit of it, but I didn't really know what to keep up doing, and I just stopped, and that's okay. Again, that's the point of not having it due the next day in class, right? And some of us might have just been so busy we didn't even get to it, right? Again, that's the advantage. Yes, sir?
On number 2, where did the 9x to the second power?
So I subtracted the x squared from both sides. So negative 8 squared minus 9x squared became the negative 27x squared.
Oh, I rewrote it.
No problem. Cool. So let's talk about what we still have left to do in this chapter, and we'll get an idea of what you got, and we'll give you guys some choice as to what you think you want to do. Yes, of course. So I have one more lesson to kind of get through for this chapter about graphing, and then that's everything that I'll have wanted to do for this chapter. So we'll do some review, and then I think we'll take our chapter, or this chapter test. Next week we have just one synchronous day, I think, for this section. So I think the test would be the following week that we come back and we'll take it in class. I guess my question for you guys is, would you rather do the next lesson now, and then we'll just have I'll have like a review day on Friday, and you can kind of continue working on the review on the synchronous day, and that'll be that next week. Yeah, so you have next week, there's really only one day where you're at school. Monday is like a B day. Tuesday is the ACT. So if you're a junior, I think you're taking the ACT. Otherwise, I think you have the day off of school. And then Wednesday and Thursday are synchronous days, and Friday there's no school. So I think you're just at school one day, or maybe two if you're a junior taking the ACT next week. Does that feel okay to you guys? So that's kind of where what I think I do like to do is just push ahead and do this last lesson, and then we'll take Friday in class to do, general questions and start on the review, and you can continue working on the review on the synchronous day. I'll have a key for the review up there by the synchronous day for you guys. Does that feel okay? Seem fair? Okay. All right. The form, and I'm going to abbreviate that as SRF, I guess. Write that probably a dozen times today, and that's just too many letters to keep writing over and over and over again. Polynomial over a degree 1 polynomial. So there's kind of two ways that we might write this. Okay, and we'll talk about the procedure on graphing either of each of these, or depending on the form it's written in. But before we do that, I want to talk about some special features. So these key features need to be included in any graph that we write for a simple rational function. The first is called a and an asymptote is just an imaginary line the graph approaches but doesn't cross. If we're talking about a vertical asymptote, that line is vertical, that's straight up and down. And likewise, a horizontal asymptote, line, the graph approaches but does not cross. Okay. So we'll talk about graphing the simple rational function in each one of these two forms. So the first thing that we need to do is find that vertical and horizontal asymptote. I abbreviate those as VA and HA because so many letters. The nice part about it is that to find the vertical asymptote or the horizontal asymptote is quite easy. The vertical asymptote is just the value for h, and the horizontal asymptote is just the value for k. After we've located the vertical and horizontal asymptotes, we draw those on our graph. Then we would find 3 points on either side of the vertical asymptotes. And then we just plot those points and draw the graph. Okay, so far?
What's that word next to plot?
Points? So let's do an example here. Let's say we want to graph y equals 1 over x plus 3 minus 2. So in this case, what is our vertical asymptote? Well, it always starts x equals, and we just said a moment ago that the value is for that is x equals h. What is the value for h in this problem? Close. Remember in the formula that it's a minus h. So it's always going to be the opposite of whatever it appears. So it will be -3. Very good. And the horizontal asymptote is going to be a y equals k, which is -2. And notice in the formula, the k is got a plus sign in front of it. So it's always the sign that it appears. So just like we did with vertical or absolute value functions or quadratic functions, the h and k were always kind of have that same sign thing going on. So we've done that. That's good. Now I'm going to make an XY table. So I'm going to need 3 points, and then my vertical asymptote, and then 3 more points. Now, a vertical asymptote doesn't get a y coordinate on there. It's just on there as a placeholder for us to figure out what 6 points basically we need. So I'm going to pick the 3 x values before, and I'm going to pick the 3 x values after. And once we've picked x values, how do we find their y values? We plug it into the function, right? So for example, if I want this value, I get -3. Everybody okay with that? If you're not good doing that kind of stuff by hand, it's always something you can do on your graphing calculator as well. In that situation, I would want to make sure that I use the fraction option. So I'm going to do alpha y equals, and then pick that first option. And then I'll do the -2 outside of it. So I can do it that way too. If you don't feel confident about your arithmetic skills, you can certainly use your calculator to kind of compute those. So I'm going to go ahead and finish these last ones out real quick. So that's going to be -2.5, -2.3 repeating. That one's going to be negative. That one's going to be -1.5. And then that one's going to be -1.3 repeating. Bless you. So I'm going to draw my graph now. Oops, really just this side of it. 1, 2, 3, 4, 5, 6. 1, 2, 3. I'll start by putting in my asymptotes. So -3 is my vertical asymptote, so I'll draw that. And then -2 is my horizontal asymptote, so I'll draw that. And then I'm going to plot my points. So I have -4, -3, -5, -2.5, and then -6, -2.3. And I'll kind of connect those. I'm going to make sure I put arrows at the ends of my graph. I want to make sure I draw my graph so it doesn't look like it's going to be crossing those asymptotes. Everybody okay with how I drew that? Okay. So then I have -2, -1, -1, -1.5, and then 0, -1.3. And then once again, I'll draw and connect those. That feel okay with you guys? Shouldn't be too bad there, right? So if I want to graph something in the other form, ax plus b over cx plus d, I'm going to do the same graphing steps. The only thing that's going to change is how I find my vertical and horizontal asymptotes. So my vertical asymptote is going to be negative d over c, and my horizontal asymptote is going to be a over c. But otherwise, we're going to do the same procedure as we did in the previous problem. So the only change is going to be how I find those two asymptotes. Not a big deal, right? So let's do an example. All right. So first step is to figure out my vertical asymptote. So notice here that my c is 1 and my d is 3, or sorry, negative 3. So that's just going to be, vertical asymptote's going to be 3 over 1. Well, let's write it all out. Negative of negative 3 over 1, or just 3. Asymptote, my a is 2, so that's just going to be 2 over 1, or 2. Is that okay with you guys? Table, 1, 2, 3, and then my vertical asymptote. So again, I'll just pick the 4 values on either side of that asymptote. Again, you can pick really any values on either side of those asymptotes, but like you don't have to be tricky about things, or like I just picked the stuff pretty close to the asymptote that are whole numbers, right? Like no reason to get all kinds of whatever about it. And then how do we find the y-coordinates? You just plug those values of x back in, right? So let's see, I get negative 1.3, and then that's negative, or that's 6 over negative 2, so that's negative 3. And then that one is 8 over negative 1, so that's negative 8. And then that's going to be 12 over 1. And then that's going to be 14 over 2, so that's 7. And then that's going to be 16 over 3, which is like 4 and 2/3. terms. Let's see, 1, 2, 3, 4, 5, 6. And then I probably have to go by twos. So 2, 4, 6, 8, 10, 12. 2, 4, 6, 8. My theory. And my horizontal asymptote is at y equals 2. And then I just need to plot my points. So 0 and negative 1.3, 1 and negative 3, 2, 8. So it would look something like that. And then the other one, 4, 12, 5 and negative, or 5 and 7, and 6 and, oh goodness gracious, I'm so stupid. So I put that at 4, not at 2. Remember I was going by twos? Come on, guys. None of you caught that? I'm embarrassed for myself. Sorry about that. And then, oops. That would be about here. So again, like really no different than the previous problem, right? The last thing we'll talk about is domain and range. So the domain is going to be everything except for whatever that vertical asymptote is. And the range would be everything except for where that horizontal asymptote is. So in the previous problem that we just did, the domain would be all real numbers except e, and the range all real numbers except 2. Everybody's okay with that? And if I went back to the first example we did, there my domain would be all real numbers except for -3. And my range would be all real numbers except for -2. What do you guys think on that one? Hopefully this topic is not too bad. This usually goes pretty well for students, as the procedure is pretty familiar, as we're just kind of like, if you can find the vertical and horizontal asymptotes, the rest of it is pretty similar to all the other graphing that we've done. So for next time, homework 4, I have 6 of these graphing problems for you to try. So I have the problem. I ask you to list the horizontal and vertical asymptotes, to list the domain and range, fill in the XY table with the vertical asymptote in the middle, and then have a place to kind of draw your graph. Yes, sir.
Why would you like have like two different things on it? Is it just like easy, just one way easier or harder?
No, well, it depends on the form of the problem that you're given, right? Like, so this problem is written in that first form.
Yeah, okay.
But technically speaking, like something written in this form is still also a simple rational function, because if you go back to this previous one, like if you make a common denominator and like add those two fractions, you're left with a polynomial that's degree 1 or less over a polynomial of degree 1, which is fits our definition. But there's kind of two ways that people like to write it.
Okay.
I would say this first way is kind of the more standard way, because we like having that horizontal asymptote easily identifiable. But yeah, that's kind of all there is to that. So it just depends on kind of the original problem, how it's written is, which one you'd want to do. Okie dokie, I'm going to stop here for today.